Hi guys, just me, Mr. Wee. I'm just here for another use substitution problem that's going to be pretty hard. So you could try this one. You could pause it and try this one out. Just keep in mind that there are values that we're going to have to find, not just a general integral or general integral function, but an actual integral value from a range of 0 to 1. So we're going to find the integral of this function from 0 to 1 in the area under the curve. Okay. So anyways, let's go ahead and try to find out what our u is. So the u actually ended up being x squared plus 4, okay? With that in mind, let's go ahead and find out what du is. Is going to be 2x plus 0, technically, because the, what is it? Sorry about this. Let me turn this down right here, okay? So the derivative of 4 is going to be 0. And then remember, that's with respect to x because we want to have values that replace the dx as well as this other x and this whole what is it, this whole term here, all with everything in terms of u and du, okay? So here's what we have left over. This is going to be, du is going to be now equal to 2x, which with respect to dx, so it looks like we can replace the dx and the x with our du term right here. However, there is a 2 here that was not in there originally, okay? So what we want to do is we want to make this side look exactly like what we have up here. So we have this replaced by u, we have dx and dx replaced by du, with the exception of this weird 2 here. So what we're going to do is we're going to divide both sides by 2, and then now we have du 1/2 times du is going to be equal to x times dx. Now this whole term that is within this function up here can now be replaced by whatever this is, 1/2 du. Okay, so now if we rewrite our integral, it's going to be the integral from 0 to 1 of 1 over u times du times, don't forget that 1/2 portion here, and in which we can actually grab that out and put it on the outside. That's a rule for integrals, that you can take any constant value being multiplied to the function and then grab it out. Only when it's being multiplied, okay? Not when it's being added or subtracted. So we have 1 over u du. Now just focus on this. Can you find the integral of something of just 1 over u with respect to u instead of x? Yes, you can. Actually, this is a little bit tricky. You might try to rewrite this as u to the negative first power, and then you might try to work backwards with the power rule, but you're going to find out that doesn't work because the antiderivative of 1 over u is going to be ln of u. And don't forget that 1/2, that's kind of in the front. So just keep in mind, if you take the derivative of ln of u, you get 1 over u, or the derivative ln of anything within the parentheses is going to be 1 over u, or 1 over whatever was in the parentheses, okay? So that's what we have so far, and then all we're going to do now is we're going to plug back in what u was. So remember, the u substitution was just a technique to find the antiderivative of whatever we have, okay, without trying to confuse ourselves. So we just put everything in simpler terms. Those simpler terms are u and du, okay? So now we're going to go back and substitute in whatever our u was, which was x squared plus 4, and that worked out pretty beautifully, okay? Okay, and don't forget, we are going to have to plug in values. We didn't just find the antiderivative function, but we have to now plug in the range from 0 to 1. So we plug in 1/2 ln of 1 squared plus 4 minus 1/2 ln of 0 squared plus 4. And now we have 1/2 ln of 5. Let's see. Did I write something incorrect here? What did I write here? Okay. And then you would put minus 1/2. No, I didn't do anything wrong. 1/2 ln of 4. And then, let's see. And then there's a general rule here. If you're taking, if you have ln of 5 minus 1/2 the ln of 4, and you have the same coefficient in the front, what that could also look like is this: 1/2 ln of 5 over 4. Okay, and that's your final answer. In the same way that if you could expand this term to say 1/2 ln of 5 minus 1/2 ln of 4. ln of 4, okay? You can go kind of back and forth here, but this is the simplest condensed version of the answer, okay? And in coding and math and engineering, we like our answers to be in the simplest terms, okay? Not an expanded expression, but in a condensed form. Okay. All right, guys. Thank you guys very much. That is the end of part 2. Hopefully, I could fit in about 2 more videos. Let's say maybe in the next 48 hours or so. Okay. Let me stop this video. Okay, guys. Thank you guys so much. You guys have a great day. Oh, and I was just watching a surf video, so that's what you see here on the screen. All right. Goodbye, guys.